All right, guys. So here's the first video of the week. It's mostly in section 4.3 for those that are looking to revise the notes. It's a little different, a lot of Desmos stuff, so don't forget to use Desmos, guys. I'll get out of the way. Desmos is where I'm gonna calculate or graph this, and Desmos is where I'm gonna get all my input-output tables. Use technology to your advantage. So, and I'll explain that in a minute. So, what we're wanting to do in those first couple of problems, it looks like, is first use Desmos to graph, which is just taking this and putting it in as f of x equals, and that'll give you your graph. Create a table of values. This is a table of values that is going to take the domain that includes the zeros, the minimums, and the maximums. So what I did is right here, I graphed it, and then I clicked on the graph to show me where these values are. Okay, so here is a 0, and this is a 0, and this is a 0. Okay? Now, once I found out where all my zeros are, I went ahead and I labeled this graph, and I kind of said, okay, well, I've got an x value over here that's -1, and I got an x value over here that's 3. So I went, okay, there's my domain. All of the zeros and the maximum numbers are in between -1 and 3. So I set up this chart right here, and I went, okay, at -1, it's equal to -7. So at -1, it's probably farther down on your graph. It's down here farther. At -1, it's equal to -7. Now to do that on your Desmos, just click on this scale, click and make sure this is is highlighted or bold. On my iPad it goes bold, and then just keep sliding the little dot down until you get to -1, and it'll tell you what the value is. So you can slide up and down on the line with your cursor or your finger on your phone, and you can find out what these values are. So what this is saying is, if I put in -1, I get out -7. -1 and -7. That's the left side. And then as I move across, I go, oh, there's a 0 here. So I click on that dot, and it tells me it's at -2.47 and 1. I mean, it's 0. And then I keep sliding across. I go, oh, at 0, this is 0. At 0, it's 1. At 0.451, right here, 0.451, it's 1.631, and again, you just click on that dot. When I go to 1 here, again, I click on the line and I use my slider, and I slide up and down until I find out what the value is at 1. And then I've got 1.45. As you work your way across from left to right, you'll be able to build a table of values, and then just put your integers. These are all the integers that you need. These are the core integers that things happen. So at -1, something happens. At 0, something happens. And then in between, you write in all your other pieces that happen. So you just work left to right on the graph. Now, so here's my table of values that includes the domain. So the domain is from x is greater than -1 and x is less than 3. So I'm in between these two. That's the domain I'm looking at. That's why I do the table of values. That's how you do your table of values. Find the left point and the right point that has all the dots, maximum, minimums, and zeros in between. Okay, so the next thing they want you to do is they want you to state the consecutive integers where the zeros occur. So let's look at where zeros occur. I'll go ahead and go to purple. A 0 is a spot where it crosses the x-axis. So this is my 0. This is my 0. And this is a 0. which makes sense. Look, how many zeros should I have? I should have 3. 1, 2, 3. There they are. Now, it says state the consecutive integers. So I have a 0. I have zeros between. What do I have in between? -1 and 0. Between -1 and 0. I have 1 in between 1 and 2. And I have it between 2 and 3. So there's 3 of them. One of them is between 1 and 0. The other one's between 1 and 2. And the other one's between 2 and 3. Those are consecutive integers. Now, the reason I know this is because the proof is because my y value goes from negative to positive. My y value goes from negative to positive. My proof, the y values go from negative to positive. Okay? So my y value, or vice versa, or positive and negative. I have a positive y value and I have a negative y value. That means it had to cross the x-axis. There's my 0. Now I have a negative y value, but now all of a sudden I have a positive y value. So this thing had to turn and go back up because it went from a negative to 0 and then to a positive y value. So again, I went from a negative to a positive y value. If you look at the graph, we go here, negative value, negative value, negative value, negative value, positive y value. So I go from a negative value to a positive value. That's why I have a 0 there. All right, so that's how you find your zeros. Now let's look at the maximum and minimums. Max and mins. Max and minimums. So if we look at our max and minimums, we're going to go right here. This is my maximum. Let's look at this here. So this is a maximum. And this is a minimum. Here, so how do we know? How do we know they're a maximum and a minimum? Because if we look at this here, my y value goes from 1 to 1.631 back to 1. So what happens here? From here to here, my y value is increasing. From here to here, my y value is decreasing. So what's happening? My y value is increasing from here to here. Now it's decreasing, so that means somewhere in there it's got to turn and come back down. That means my maximum is at 1.63. Same thing here for our minimum. Our minimum, I have -1, and it goes to -1.113, and then it goes back to 0. This is my y value. So what happens here? If you look at it, follow the graph from -1. So, I'm sorry, not -1. Yeah, -1. -1, my y value is going down. It keeps going down here. My y value is going down, and so it's decreasing. And then from -1.13 up to 0, it is increasing. So what does that mean? If my y value is going down and then it turns and goes back up, there's got to be a minimum somewhere. There's your minimum. Same thing here. My y value is increasing, and then it starts to decrease again. Once it gets to the maximum, my maximum is right there. Okay? So that's how you find maximum and minimums, zeros, and all those crazy things. But remember, use Desmos to help you out graphing that. All right, so one more example of a couple of different things. So if we have, let's say, draw polynomial. So we're going to draw a polynomial, and we're going to draw a polynomial that has zeros at -1, 1, and 4, and it is an odd function, a negative odd function. So what does that mean? Let's just kind of look at it. Negative. So negative leading coefficient and odd degree. Let's be a little more specific. So let's look at this here. So if we draw our graph, right here, we know I have zeros at -1, 1, and 1, 2, 3, 4, 4. I know that I have a negative coefficient, leading coefficient, and an odd degree. So this tells me my end behavior. So my end behavior here is going to be as x approaches -infinity, y is going to approach +infinity. And then my other one is as x approaches +infinity, y is going to approach -infinity. So, as x approaches -infinity, y approaches +infinity. As x approaches +infinity, y is going to approach -infinity. That's what's going to happen on the end behavior. Oops. So what happens in between? We really don't know, other than we know that there's zeros. And if we think about what we talked about from the zeros, zeros have to cross from a positive to a negative, back from a negative to a positive, and then turn and go back from a positive to a negative. That's the definition of zeros, where my y value goes from a positive to a negative, and my y value goes from a negative to a positive. It's got to cross the line. So that's my drawn polynomial. Label your zeros, figure out what your ends do, and then draw any graph you want. All right? Last thing, guys. It's an old one. Don't forget when it says solve the polynomial. Solve for the polynomial. You factor and set each factor equal to 0. Okay? So don't forget to factor, and then if you guys have questions on that, we'll tackle it in class. Remember, this is section 4.3. For those that were revising their notes, talk to you later.